Welcome to the noontime briefing by the Department of Water Resources on the Oroville Dam spillway emergency incident. I will be introducing Eric C., who is acting as an information officer here for DWR. He is a environmental program manager. After which Bill Croyle, the acting director for the department, will be available to answer your questions. At this time, we want to express our regrets to people trying to call in with your questions that the phone line is not working today. That's with our apologies. We will try to correct that for the next briefing we have here. But I have tweeted my phone number, and I'll give it to you if you'd like to follow up with questions, and I'll be busy collecting your questions all afternoon, I'm sure. My number is 916-335-2299. 916-335-2299. Eric C. Doug Carlson, Information Officer. Eric C. is Eric, traditional with a C, and S-E-E last name. Eric?
Thank you, Doug. As Doug mentioned, I work here at with the California Department of Water Resources here in Oroville. And I want to just start out by showing a picture. This is from quite a ways away on top of the Lake Oroville Visitor Center. There's a live webcam, and this is looking down at it, and so we just have this projected. This is water flowing over the auxiliary weir, or auxiliary spill structure at Lake Oroville. And so it's the first time that the structure's ever been used to spill water. So Aaron, could you put the map up? So as I mentioned, this is the first time that the spill structure has been used. So I'll go ahead and point out, right, we're talking about this structure that extends, I believe, for about 1,700 feet from right here over to here. This big flat area right here with these, you can't see it very well, I know, but these little dots are boats and trailers. This is the parking lot for our spillway boat ramp. This is a very unusual event for us here in Oroville to actually have water flowing over this weir. This is a design structure. It's a feature of Lake Oroville here to have this spillway. It is a reinforced concrete spillway. And the parking lot here is part of it. And this reminds me of a story back in about 1995 or 1996. The Department of Water Resources was funding a project, a recreation project, an improvement project here to build concrete bleachers. So bass tournaments, when they would go fishing on the lake and come back to weigh in their fish, they would have places to sit, and we're going to set up this viewing facility. So we put the bleachers way up over here. But originally, the plan was to put them over here so we had a nice, beautiful backdrop of the lake. And I remember at the time, our dam safety engineers told us, well, you can't put them there because the spillway parking lot is part of the design, or is part of the design of the emergency spillway, the auxiliary spillway. And I thought they were crazy. I said, you know, the water would never, you know, we've never used it. We have this large spillway over here, and we had this big argument because we were trying to, you know, for better recreation, and ultimately the dam safety engineers won, and the recreation managers lost, and so we put it over on the side over here where it's out of the way and doesn't cause any effect on the parking lot. And I'll tell you, you know, the same guys that are next door right now working on these repairs and everything, they're the ones that made that decision, and you know, I'm glad they did, because you know, it really, you know, these things that you don't think would ever happen, you know, it's really interesting to see, you know, that we are actually using this feature now. Lake Oroville was built in during the 1960s and was completed in 1968 and filled, and we've never used this feature. So just wanted to point out, so it's an unusual situation for us. As far as the amount of water that's flowing over the emergency or the auxiliary spillway, it's not a lot of water. It's a relatively small spill. Right now, I believe the spill is increasing slightly, but it's projected to come up to somewhere in the range of 6,000 to 12,000 cubic feet per second, maybe a little bit less than that. We're giving a range because, you know, some of this is dependent upon, you know, some sloshing in the lake, if you will, if you get some wind, or so it's hard to get an exact number on that, and it's based on projected, you know, it's based on modeling, which is projecting inflow to the lake. Snow melt, there's a lot of different things that have to be factored into that, but relatively speaking, it's a small spill. We are still continuing to use our our primary spillway, which is this structure right here. There's 55,000 cubic feet per second flowing down the primary spillway right now. This is the feature that has the damage to it, the erosion that we've been talking about for the last several days. And so we are continuing to spill water down that structure. Knowing full well that we're basically sacrificing the lower portion of it. You know, we're having continued erosion, and that's being monitored continuously. As long as the erosion doesn't get beyond what our dam safety engineers and project geologists think is a safe condition. So we're continuing to monitor it continuously. We have cameras on it. We have people observing it around the clock. So we're continuing to use that spillway. We anticipate that the duration of the spill that is currently going over the auxiliary spillway will be somewhere in the neighborhood of 38 to 56 hours. So that's a range of 38 to 56 hours. We think during that time period, the lake will actually drop and the spill will cease. So the inflows to Lake Oroville, because the storms have finally stopped, are gradually decreasing. So and that's going to slowly lower the surface of the lake over time. And as I said, we anticipate that spill ceasing somewhere between 38 to 56 hours from now. And I guess that is, let's see, that's all I have for now. But I did want to introduce the California Department of Water Resources Acting Deputy Director, Bill Croyle. Acting Director, I'm sorry.
Yeah, thank you. Good afternoon. Thank you for being Bill Croyle, C-R-O-Y-L-E. Again, Acting Director. I think I misspoke earlier. Acting Director of Water Resources. So what I'll do is quickly kind of run in a little bit more detail on some of our efforts, our challenges that we have in front of us, and what that really means for the dam itself and the levee system and the public downstream. So again, we have quite a bit of damage, as Eric said. What we call about station, the hole or the erosion started at station about 3250, so about 3,200 feet from the radial arm gates. And then as soon as this happened, we spent quite a bit of time looking at what our options were to try to repair that damage. At the same time, remodeling the reservoir, both inflow and the forecast that was in front of us. And so it took us a little while to make sure we vetted all of our options were to get into this hole once we turned the water off, including putting people down in the hole to assess the underlying geology and the structure itself to see, A, what we could do to repair it, but also, if we couldn't repair it, what kind of erosion or impact we might see. Frankly, not so much what of the infrastructure downgrading or down the spill, but looking really upgrading it, knowing that we have competent structure above, but we need to understand what that is so that we can monitor with the amount of water coming down here. Is an awful lot of energy, and the energy has the potential to cause more damage. Or what we see is we're monitoring how fast the erosion up this spillway occurs. So that is stabilized. The water now we run, as Eric said, is 55,000 CFS. And we're running clear water down to the base of the river, which is good news. That means our system is stabilized. But with that, between when it started and now, we've identified a number of concerns that we have. And again, we're working through the contingency plans and implementing those plans to prevent more damage to our spillway system, protecting our powerhouse here at the bottom of the dam, and then better understanding the impact of the use of this auxiliary spill well. I got it right. So one of the things with all this material coming down the hill is we have a pile of sediment at the bottom of this. A lot of material came off the hill, and I know I've been talking since Tuesday about this is not going to look the same every day. You know, we're seeing more material come down with today's flow over the weir. We did a lot of work to try to remove some of the debris from the upper portions of this spillway to protect ultimately the basin and downstream control structures at the dam and then downstream Feather River. And so they did an awful lot of work, amazing amount of work in a couple of short days, removing trees, reinforcing some of the areas that we, watching this happen, understanding the energy, go in and reinforce some of those areas to add another level of reducing that risk or improving our safety factors. The downside with some of this is, of course, this is very bad. We're going to fix this. We already have the team set up to work on coming up with our repair strategies, is dealing with this pile of sediment and rock and debris that's down here because it's backed water up to the powerhouse. So one of the concerns is making sure backing water up to the powerhouse threatens the use of that powerhouse and ultimately how soon we could put it back in operation. So we are looking at contingency measures to reduce this water level, essentially removing some of this material to release this water and to flow downstream so that we can make sure we protect this powerhouse. We do not want any part of the powerhouse flooded and contaminated with this dirty water. So we've done that. One of the other challenges we have is there's three ways to get water out of behind this dam. One is the powerhouse, one is the spillway, and the other is the auxiliary spillway. So we have a damaged spillway and no powerhouse right now. So we've, for the first time, as Eric indicated ever, we're using our auxiliary spillway. This spillway is designed and is really designed on all dams to take what they call a maximum probable flood. So that means when Mother Nature really throws the biggest storm at these structures, the engineers designed this basically to protect the dam itself, to ensure with a super huge event, the dam still stays there, even though the impact of that event that went through this channel would ultimately cause havoc in the valley. Okay, the flows we're seeing across this are extremely low compared to the design of this structure. And so that's one of the things, this is working to help protect the resource we still have here and also give us time to, again, mitigate the concerns or the impact on the power plant so we can get this back into operation and increase the flow from the dam via the power plant. One of the challenges we have is there's power lines that come through this region to the plant that connect the plant to the grid. This plant cannot operate without being connected to the grid. So this is, at the time they designed this plant way back in the 60s, was not the kind of plant that you can take offline and still run water through the power plant. Okay, that's just the way it's designed and that's what it is. So one of the concerns we have to maintain, if we're going to use it, we have to maintain the connection of the plant to the grid. But we have a tower right here. So the concern is as we have erosion down gradient here, we want to make sure that we don't erode too much soil or material that impacts that tower. So again, we have monitoring on it, we have cameras on it. We're continuously assessing the rate of erosion. Again, that stabilizes. The last information I had was 24/7 monitoring. Right now, we're not using the power plant, so if we lose the line, it doesn't impact the plant. And we're working with PG&E, and I see him here, so thank you very much, because PG&E's been a huge partner as we come up with addressing the issue on the power plant and hooking to the grid. There are towers and their lines, but they also have lines that they've gone in yesterday and removed poles and wire through this outflow structure. And again, but they're maintaining a power source to the plant so we can do what we need to do, operate gates, and et cetera. So we have a concern and a threat here that we're working on. We have a concern here that we're working on. And then now looking forward, similar to this threat, moving water down through this system also puts more material in the diversion dam pool. So the contingency measures that we're looking at here and implementing to reduce the flow in this area, get this water out of here, so hopefully we can turn this plant back on, will also be the same contingency measures we use over here, again, to do the same thing. Now, we do have a lot of water coming down through here, so that'll help keep the sediment out of pulling up and building like a sandbar that we see here. So that's the kind of the dynamics of some of our contingency planning right now. Okay, we're dealing with what's happening right now. We made it through the wet part of the storm. We're on the back side of the hydrograph, so it's coming down. The lower that gets, these flows will reduce, and then we'll get back to digging into the storage and getting some more water out of the reservoir down this chute. Okay.
Future forecast, rainfall.
Yeah, future forecast, Doug, thank you. So we're going to have a period of dry weather here. It looks like, I think, in this area Thursday, look like we'll see some weather. It'll be a big difference in the storm that we just had. So I think I just saw the 10-day forecast for this region came out. So we look, I think, 4 or 5 days of some rain, but the key is that it's cool. It's cold. The snow level went from 9,000 in this last storm, which is quite high, down to 4,000, which is more typical for this time of year. That's key for us because it'll fall in the form of snow and stay there. It won't run off and fill up our reservoir, at least right away. So thanks for that, Doug. Part of this is what else are we considering or are we worried about? We're worried about, we do have a storm coming in. Based on our current conditions, again in 32 to 56 hours, we should see the flow over the Weir stop. We'll continue to push 55,000 CFS down the middle of the reservoir, and then we'll see more storage generated in the reservoir and enough storage to make it through the next storm without threatening the use of this. But we'll see, you know, we're 5 days out from the forecast. This is Mother Nature kind of kicking us a few times here. And so we will continue to model the inflow and the outflow of this reservoir 4 times a day. And then we change our contingency plans and the decisions we make based on those models and forecasts. So we do that here, and then we'll push that information out through our JIC and through meetings like this. And so that, you know, what that means for the dam, the community, and those levee districts all the way to Sacramento will be informed. Again, the JIC is standing up. It's going to be resourced more, so we'll be able to be more functional with all forms of communication. That will help keep everyone well informed of what this means. And backing up to our current situation, the dam is not threatened by these conditions. These flows coming out of the dam, I hate to say it, from any one of these 3 options are typical flows for this kind of runoff period. We're going to see flows come up and down based on the storage graph or the hydrograph of the storms coming in. The big difference here, normally you wouldn't see these changes and we wouldn't be talking about this very much because as those big events come in like this last few days, the storage pool within the reservoir attenuates that and you don't even see a change in the river itself. But these flows are regulated by the Army Corps of Engineers and we're required to release those flows at a certain rate. The problem we have now is we've lost the ability to dial outflow here, and we're uncontrolled here. So the only way we can really move these things up and down is here, and we're going to be limited on what we can do through the spillway because we want to maintain integrity with the system we still have. Okay? So we have 2.8 million acre feet of water in the form of snow above this reservoir. Now that will change with storm events and melt, but we have right now in this part of the state, we're exceeding the record rainfall rate for the season of 1982 and 83. The total rainfall at that time for what we call the 8 station index was 83.3 inches. We're not there yet, but if you look at the curve on what the hydrograph, the rainfall for that year is, we're far above it as of this date. So if we continue this wet pattern, which would be, you know, a wet pattern, then that puts us above that 82, 83. So we got to deal with that, but we also have to deal again with the snowpack, which we desperately want, right? We've gone through 5 years of drought, and the snowpack is one of our really critical water storage reservoirs in the state. We haven't had that the last number of years. Now we have a lot. I think last I looked, it's been a couple days, 156% statewide on our snowpack. which is a good thing coming off this dry areas. But in this kind of a situation, our next 60 to 90 days will be critical, how we route this runoff, typical runoff period through this reservoir and then into the Feather River. So we're going to do that kind of winged on our damaged spillway. We want to obviously get our power plant back up and functioning, because that's one of the ways we can increase or decrease our flow out of our reservoir. And then when this flow stops, the auxiliary spillway, we're going to go back into this area and continue to clean and grub this area out to the extent that we do get a bigger storm event and need to push more water over the spillway. This spillway by design can carry 270,000 acre-feet of water, okay? It's the most water that's been down it in the past is 150,000 CFS. And the reason for that was really the downstream capacity of the levee systems, which is, as I recall, about 160, 170. Okay, in other words, flows like this we can easily pass with no flood threat to this community and downstream levee systems. Now, if we get into a big storm event and we don't have the pool and the reservoir that we need to attenuate that, then these flows, uncontrolled flows, will be a threat. So that'll be part of our forecasting and communication with the public. If we see those storms coming or something that looks like it might produce a runoff like that, then that's what we're going to need to talk about. And that's when we, through our Flood Operations Center, which are activated today for other reasons, would communicate with the local managers, the state emergency managers, the levee districts, and the communities that were threatened, if that happens. But I just want to put that out there. There's a lot of snow up there, and we're going to be really busy dealing with the infrastructure challenges that we have, but also continuous routing of our weather forecasts through the reservoir at really all times, and communicating our findings out to our partner agencies responding to this situation, but also all of you and the public.
Bill, snowpack is now 180% of normal for today's date,
okay.
And rainfall in Northern California 228%.
Okay, so reiterate.
Yeah.
Yeah. So snowpack statewide?
180 statewide.
What is 180%?
And rainfall 228 in Northern California.
So 220% in Northern California. Is that the 8-station index?
Yes.
Okay.
228%.
228% in the 8-station index. Okay. So I think I covered a little bit, and I anticipate your questions, so bring some good ones. So again, the storm we just had, took a little water over the auxiliary spillway, but again, based on our forecast and our modeling, this will peak, again, 32 to 56 hours, and then we'll start making room for the next storm. But as of today, we shouldn't see a flow over the auxiliary spillway. When I say that, though, things have been very dynamic and change, and we could still have a spill. But we will keep you informed on a daily basis of the latest information we have. Again, the storm is projected to come in cold or snow level at 4,000, and that's a good thing. That gives us a little time to, again, address our on-site conditions. Before I forget, we will be looking for an opportunity for some dry weather. We've looking at designing a contingency plan to further protect the spillway itself, which means we might have to turn it off to install it. Okay, so we would turn this system off, jump down in the spillway with our equipment, install that protective measure, basically protecting the edge that's eroded off or broken away so that it doesn't continue to degrade. Okay, so that's key for us. So we will be looking for an opportunity to jump in that canal or the channel and do that. But I want to kind of put that out there because that means we will turn off the spillway to do it, right? And so that will bring up questions like, don't you need to get the water out of the reservoir? Yes, we do. But we want to do that so if we can, is increase the amount of water we can move through this spillway at any given time. Hopefully that makes sense. If not,
you would do that even if you're encroaching in the flood space.
Yes, yes.
Yeah, clear weather.
Yes, we would. Okay. Yep. Long range. So again, we're going to need to work very hard, work closely together. as we move through the runoff period, again, typically next 60 to 90 days. It could be longer. If it stays cool, that's good because the snow will come off slower. That gives us, again, more time to get water out of the reservoir. But we need to get back in and start rebuilding this system. The team's already been put in place. The options are being considered. We want to go back into next winter with a rebuilt spillway. I also want to say it might not be here, okay? Because we're going to need to design fast and install fast. So it might be somewhere else related to the dam structure. And then we're already talking about our options. If you move it over here, which could be drier faster, and we can get in and start working and still continue to use this, we want to go back in and what does that do to this structure itself and the ability of the reservoir to pass that maximum credible flood.
Ready for questions?
Maybe to reiterate, then we'll move the questions, is the flow rates we see now, even with the use of this auxiliary flow rate, pose no threat to the dam and no flood threat to the downstream water. Okay? For this storm we just had, and the storm, based on our current forecast, the storm we're about to get, say next Thursday or Friday. Anything past that, we got to wait for Mother Nature to kind of send us some signals on what that might look like.
So just to reiterate your point, the residents at this point don't need to fear that they may have to be evacuated, that there's flood danger that would go into populated areas.
Right, that's exactly right. Down in Orville. But it's a good question because one of the things I want to highlight, because of the snowpack we have right now in the Central Valley and the San Joaquin Valley, we have reservoirs or at their flood control. You know, most of them have a lot more storage space where they're supposed to be. But as an example, Shasta Lake was encroached a little bit during this storm to allow Cottonwood Creek, Battle Creek, and others to push that water out. Now those streams and rivers are going down. Now Shasta will bring up and be able to dump the water out of Shasta by design so we don't overtax the flood control system all the way down past Sacramento into the Delta. So we've already opened, as an example, the Sacramento Weir. And so a question came up, are you opening the Weir because of Oroville Dam? It has nothing to do with Oroville Dam. It has everything to do with the regional management of our high water situation that we have right now. I think the American River yesterday was 80,000 CFS, pretty high. And so we're managing the flood control system through our Flood Operations Center in concert with our emergency management agencies, Cal OES, the levee districts, and they're doing daily conference calls right now. I think down the McCullamy, they had a levee break this morning. I think that just goes to show that we do have some high water conditions in and around the region. Right here, we don't have a high water condition, but we anticipate the need to manage high water for the remainder of this spring runoff period.
Help me with the math problem. The inflow is still in the neighborhood of around 90,000 CFS. You're pushing 55,000 out the main spillway. Why won't the auxiliary spillway go to 35,000 or something in that neighborhood?
Yeah, because that's what gets into, as the streams hit the reservoir, so that inflow, the reservoir itself has a kind of a buffering capacity. So as it hits the reservoir, there's a lot of reservoirs, I think 16,000 acres?
Yes, surface.
Yeah, surface that, so you're filling up this much, but when you're at the top of the dam, 6 inches is a lot of water. So it's kind of like this, it surcharges the reservoir, but so as it goes across the reservoir, it kind of flattens out. And so that's the part that's kind of the math part, and that's why the engineers get paid what they get paid, is to model the impacts of that given certain kinds of hydrologic settings. So just because you get 150 in the reservoir doesn't mean you're going to get 150 out, 6 hours later. You might get 90,000 out. It's just because of the ability of the reservoir to kind of expand and contract to the point. It's a big reservoir then coming down to a little outlet. So it takes a lot of time to get there. And that's why we model this stuff every in this time of year, we're doing it every 6 hours to go back and check our math. Check the inflow, rerun the models, look at our outputs. In some cases, in best case scenario, we'd be opening and closing gates and hydro systems to match our inflow and maintain our flood control space.
Now, since the power plant is shut down, for, I guess, the foreseeable future,
For little, we're trying to get it open as soon as we can.
okay. I mean, why was it so important to dial back the releases yesterday evening in order to protect that transmission line, since the power plant shut down anyway?
Well, because we're also trying to protect the spillway itself, right? I mean, it's a lot going on. And so we want to maintain the integrity of this spillway. It's critical. So we want to make sure that if we push less water, there's less erosion, even though it's less water, and we put a little water over the auxiliary spillway, this will protect this structure for the duration of the time we need it. If you let this thing rip at 100,000, as an example, we haven't run the numbers at that, but that may accelerate the degradation of the spillway unless we can get in and do something to prepare it for those kinds of flows. We haven't done that. That's that dry weather opportunity that we're looking for, right? So we're trying to protect this system here, which includes protection of the tower. At the same time, it's kind of related, but we have these secondary impacts that we got to be careful and watch out for. And that's the contingency and that reassessment on a continuous basis to understand, kind of the serial type impacts that you might have or the secondary impacts you have by making a decision, right? If you're worried about this, but you weren't watching the water backing up into the power plant, you could take out the power plant even though you've saved the tower, right? And so that's why we have a number of different teams of people. Your job is to protect the power plant. Your job is to monitor and assess the challenge. Another team is working on, making sure we understand how big this pile is and what are our options, 3 different options to remove part of that to get that water to release.
And with so much water coming down, how could you conceivably start removing debris from the bottom?
Well, that kind of slowed us up for a couple days, but those are challenges. So, floating barges in, and again, as we look at, again, not only this, but recognizing as we have used this, we need to fully understand how much material will come in here and what is the impact. So our contingency measures need to consider this as well as this now. Even though we might not ever need it here, what is that measure? So, long reach hose on barges is an example of that. That's a typical solution that we would use in agriculture. So the equipment's close by. It's something we would use in the Delta to be able to reach out in a, we don't want people down in here. That's why we're here, is to go up and validate what people are telling us on the phone. We're get down here and get the hose down here and pull this dirt back. And they said, no, you got to come here and see how dangerous this is. And that's one of the other reasons to back this flow off, so we can stop the erosion, get in here to be assessed, and go and then be able to kind of carve this back out if we have to mechanically.
Any idea how much we could be looking at in damage, repair, and cleanup of probably hundreds of millions of dollars a year? How long a period of time they would be working on this thing?
Well, my objective is to get a spillway back in operation before the wet season next year. So typically that's October 15th or so. It all depends on the year. If you go back a few more years, it went dry for the whole year. So we didn't have a wet season. But October is typically kind of our formal start of flood operations down the Flood Operations Center. That's a lot of that's is eyes and ears and making sure everybody's got the right phone numbers. But we need to watch the weather because we can get some big weather in October. So that's kind of, for me, we need to have structure in place to be able to pass our design flows.
Do you have financial people already looking at this in terms of what you're talking about dollars? And can you give us a sense?
A very
of the
rough,
magnitude of this?
yeah, a very rough range. And I say that, again, we haven't gone in and looked at it. We don't know how much more damage we're going to do. Decisions have to be made on a new one over here or a repair of this one. So the range is huge. But it's I was told yesterday.
That's the very
Well, what we told the governor yesterday is 100 to 200 million. Again, with the caveats, we don't know a lot about the site itself. Okay? So the resource, we just met with some congressional representatives and some legislative, and so that issue came up, is, you know, funding, state and federal resources. We have the resources we need to start this process, and we will get it done with what we have and with the support of the administration.
Can you explain how you can see from the other side of the river with the water whipping over the auxiliary spillway, but it's hard to say where it's flowing. Is it just whipping down through these trees? Where is it flowing and what's it taking with it?
Yeah, I don't know what's taken with it. I haven't been up there,
You
and
can
it's
see
just,
it's like a
yeah.
big wall that's curled down. So
Yeah.
you see the water, but you can't see where
yeah.
it's going.
So we did walk it, I personally walked it last night so I could better understand the dynamics of this and making sure that our teams have done everything we could possibly do. So and I don't know exact elevation, but this is like 40 or 50 feet high right here. But over here, it's like 6 inches high. Solid rock. All this is rock. So at a low flow rate, again, I haven't been out there. The picture was great to better understand what it looked like. But we're looking at it from this side. But when you walk it, this is pretty flat up here, right? So it's going to be sheet flow, and it'll gently go over here. A lot of the flow, in my opinion, will go over the top here, but come down this part of the spillway, down this ravine, and then kind of follow where these trees go, right through here. Okay? Now there is this ravine here that comes down and then marries up in this area. This is a pinch point, and we've modeled this now. So we understand where we, at a certain rate, we looked at this at 35,000 and 55,000. What did that look like? And so, again, it's kind of, once it comes over the weir, comes into this area, it's broad and then pinches down and then broadens a little bit out at the bottom.
And the other thing is, it's kind of a spectacular site. Maybe you can explain what PG&E people can't. They're helicoptering men onto these towers, and they're cutting the cable and taking it off and bolts and stuff. Can you explain exactly what they're doing, and are they going to take the full towers down, or they're just doing some safety stuff to keep dangerous stuff out of the river? What is it that's going on there?
Yeah, I don't know if you guys want to talk about that or not, or. Okay, why don't you come up, and then just in preparation, let me go to another question as you're coming up.
Really quickly, with the event that you talked about in that in the next few hours, a couple of days, what do you expect the turbidity, or do you know what it's going to be when it takes that material down? How big a spike?
We're going to see a very large spike in the turbidity. I can't give you. Yeah, I can't give you a number.
Is it a gradual or continuous spike?
Well, we have a lot of turbidity in the river. Now this is cleaned up. If you look at this area, this is pretty dirty. Now I guess I'm going to go back to my conversation with the Director of Fish and Wildlife yesterday with the governor. So because of the concern with turbidity and debris getting down into the fish hatchery, they were able to evacuate over 10 million salmon, both fall and spring run. An amazing feat. A lot of teams came together, moved those fish out.
I was there.
You were? Okay, great. And so the key there is there was a recognized threat and action was taken to protect that resource. But talking with the director, he said they had spikes, I think yesterday, at about 2,000 NTUs. And so that's pretty high. And so that's the point that's going to cause trouble with any of the fish that were left behind. So those are the kind of numbers, obviously, we don't want to see in this reach, but we're likely to see because of the nature. The spillway's never been used before. And going back to that little pinch point that we modeled, fortunately, somebody historically mapped how much soil is in that area. There's a couple little tight spots in there that look down to dip down a little hole of 60 feet worth of soil, right? So if we get a chance, if some of that stuff doesn't get moved by this overflow event, we're going to get in and move that out of the way. So again, if we happen to have a future spill, then that's not going to end up in the river. But, it's going to be dramatic when it hits the river. Is that a spike? I'd call it a spike, but it'll be dramatic. and then it'll be attenuated by the other flow that's coming down. But we will increase turbidity in the river.
Get the PG&E gentleman
Yep.
there.
Sure.
Can we get your name, sir?
Sure, it's Danny Boyles, DENNY BOYLES. I'm a PG&E spokesman.
Can you explain what's going on
Sure.
there? And are these lines connected to the power plant that you referenced?
So our transmission line in this area actually predates construction of the dam. So what we did yesterday, you can see just barely, there was a transmission line. It's 2 circuits of 230,000 volt lines that crossed the Feather River at that point. We removed, using crews carried by helicopter in a long lining method, we removed the spans of wire between the tower just beneath the dam in the photo here, and then the spans of wire, if you move it up here as well, with the idea that we wanted to, in an abundance of caution, minimize any material that could go into the river if those towers are eroded by the flow through the auxiliary spillway. And we completed that work. We have removed all the wire and conductor from the towers. Unfortunately, water began going over the spillway before we could remove the towers themselves, so they are still in place.
Bill, you mentioned a couple of times options for what's going to happen with the spillway. You talked about possibly a new spillway. Can you talk about the hole itself? A couple of questions on that. First, you mentioned that we're running clear water over the spillway. Does that mean erosion has come to an end on the spillway? And then secondly, what are the options more specifically? Are we going to dump rock in there, put something over it?
Okay, so that's a good question. So as we run clear water, being a flood fighter, whenever you see a boil or any water moving through a levee, if it's clear, it's good. Even though this water moving through a levee is not good, but if it's clear, that means it's not carrying material. So when we saw by reducing the flow from 65 to 55 yesterday, we were able, it took a little while for it to kind of settle down. Again, that allowed us to better monitor the condition of the tower and the areas around it. And then also, we were hoping, and it did, clean up. So it started running clear. Now when you ask, is it still eroding, or did it stop eroding, I don't want to go there because it's running clear, but there's a lot of energy in this system to move the bigger stuff. Running clear means there's no the soil or clay particles and sand moving through, but we still have a lot of energy moving down through the system, so we can see rocks and boulders and other things continue to be pushed down. Now, if your question is about the hole, in the spillway?
You were exploring options for a rebuild.
Yeah.
When you talk about specifically the damaged spillway, what are those options?
Yeah, basically, it's a complete replacement. And so, part of that complete replacement, in super simple terms, is you're going to grub the whole area, pull everything that's there out, and you're redesigning using all of the latest materials, all the new building standards. It's a higher level of safety, going back in and basically using best management practices into this spill here or in some other location. That decision needs to be made. Now, part of the key is where do you start and stop? Okay, in my opinion, it's toast all the way to the bottom. So we got to start from here and move up. If we're going to stay here, we got to start here and move all the way up to some point.
All the way to the top.
Well, it'll be the engineers are on it. There's, better experts than me on this by far. But, so part of that is if you start trying to rebuild, let's say we want to rebuild or update this gate, that's a completely different project. This is huge. This work is huge. A lot of flat work, a lot of groundwork, but it's completely different than anchoring in a radial arm gate system with all the control systems. And so the time it would take to replace the whole thing really doesn't exist by next year. That's why other options need to be considered. Should we move something outside? What are options? Maybe there's other options that we haven't thought of, like in the dam itself. All those things are being investigated now.
So by saying that, talking about repairing this one, but having something else in next year, are you ultimately going to have 2 spillways?
No, I'm sorry, I didn't mean to insinuate that at all. We got to make a choice on where we're going to do our work. If we do work over here, that impacts their ability for this spillway to pass water, which needs to be factored into the overall protection of the system. If the decision is, and we're a long way from making that decision, long way, in time, but it's got to happen fast, is making the decision if we drop back into this region, we got to make the call on how far up we go, and we're obviously going all the way to the bottom, and what that means, and what is the technical approach to do that. In some ways, this is, for some of us engineers, this is hurtful. Tearing up an engineered structure like this is huge. But with all this water moving down, it's helping us out, because we're going to have to tear it all out anyway. This is, now, I think on Tuesday there was a lot of heartburn on making that decision. You have to let it go. It's gone. And so once you get over that, you can get on with solving the other problems, and we did.
Do you think you waited too long to make that call?
No. No, because there's a whole bunch of conversations and the decisions that are being made on different parts of this. But at the same time, we're looking at how fast can we get trucks in? Where are the trucks? Where is the rock? How much material that is? We had to shut it down. We put people in the hole. At the same time, we're looking at all the other options. And it's going to take some of the time it takes so that you can kind of validate your assumptions. At some point, you got to make the call and move forward in the direction you want. So it's emergency management 1A.
If you build a new spillway at a new site, just to the left on the photo, you have to build new gates as well and a whole new thing. That would seem to be a lot more expensive.
Maybe not. I think those are the numbers we have to run with. But you might be able to take more time to do that if you can, again, better understand the dynamics here in the erosion, do things to help protect that, and then, if you can get this good to pass the next year, given certain engineering assumptions, you might go ahead and do that. But again, those decisions are all in play right now. Lots of people, the teams come together, the direction's given, numbers about costs, everybody's thinking about how to pay for that. They'll reach over to the federal government. We'd like to see some critical infrastructure dollars.
So when's the last time that the main spillway was inspected, and what's the best area to what started it? Is it just the spalling of the concrete?
That's a good question. So we've been, that's one of the things that we went back. We're talking to the Division of Operation and Maintenance on their inspection records or their logs and stuff, and so all that stuff's being vetted through. We've been through the Safety of Dam, which does independent inspections. So they're the regulatory agency in California that gets into this. So they've gone back 10 years. There is a picture that's floating around on the internet that's dated about 2013 with some trucks parked on the kind of crossway in the spillway, what looks like a seep. We've had the conversations about what that is. And what we think that is part of the normal maintenance that would occur in this kind of a breach, where you go in on an annual basis, you clean out the joints, you pressure wash those joints, and you reseal them. Okay, so the inspection records, which include people walking down this chute, which happened, the last one I saw was 2015. Again, that's an annual deal, and those are available to the media. So if you want them, you can have them, so you can read it for yourself. But there's people physically walking down and inspecting and recording and taking pictures of the condition of that chute.
The July 2015 one, though, said that it was only a visual inspection, that it was not walked.
Yeah.
Does that present an issue?
It doesn't to us.
So last night, we heard that you guys weren't going to be using the emergency spillway, which you guys are now calling an auxiliary spillway. So what happened with the calculation that led
Well, the storm came in. It was pretty warm in the beginning of the storm. It kind of parked over us for a little while. Again, these models are occurring every 6 hours. They're remodeling. And so based on that models, we're making decisions based on the best available information. But I was here last night with probably many of you, and when we went home, it was raining pretty hard. And those kinds of events, I'm not saying that caused it, but the change in weather conditions have a dramatic impact on the inflow to the reservoir upstream, and then how that inflow is routed through the reservoir system. So that's part of the error bars we're dealing with. We have 3 different groups modeling independently One of them is the regulator, in this case, the safety of dams, trying to work through the numbers. And if we have a difference in our perspectives, that's the calls that I'm on to make sure I understand what the issues are, how far apart we are, and making sure that we're addressing that. And so this is, to me, this is part of Mother Nature's involved in this. That, you know, sometimes you're on the better side of it, and unfortunately last night we're on kind of slightly over. I think our team and working with our partner agencies has done an amazing job to crank through the numbers. I think we do a better job, and we will work to improve our job to make sure that you have the latest information through our JIC here at the site, to make sure that the information that you're receiving is from this location and with the best available information.
And I was speaking with some people who were preparing to evacuate yesterday on Montgomery Street, and you said that there might be storms coming in at the end of the week, so would you be issuing evacuations again if that does happen?
Nobody's, to my knowledge, has issued evacuation notices.
That's correct.
Yeah, so, but I understand the concern. There's a lot of water behind the dam. But as I said earlier, the flows that we're seeing from whatever source out of the dam right now are like less than a half of what we would normally see in a really tough flood event that would stress our systems. So there's no reason, in my opinion, based on the information we have now, which is available to you, that we should be worried about evacuating any part of this region, you know, given our weather forecast conditions. Now, saying that, getting back to how much snow we have above this reservoir, we're going to need to stay continuously in contact with any changing weather conditions. The looking forward is about 3 to 5 days. When we see a big, if you see one of those Pineapple Express or atmospheric rivers that we talk a lot about, if we see one of those lined up, you know, not just in somewhere in California, in this region, then those are the kind of things that we really amp up the communication, the modeling, and making sure that we're all on the same page on what we think the threat is, right? Now, our error bars are far less now, so we have to be much more precise in our work and also communicating to you on what that real threat is.
And why are you guys calling it an auxiliary spillway now instead of an emergency spillway?
That's the name we've been using as of, I think, yesterday.
Why is that?
That's the number that they're using at the local level here.
Eric C. has some more comments to be made about recreation here. Eric?
Yeah, just one more question. Are we good?
What is the exact?
Let me get back here and we'll come back here.
Town of Thermalito, is there any risk
No,
to that at all?
no, not, well, based on our current situation, there's no threat.
What about the erosion in the spillway itself? You said the hole was at about 3,200 feet. Where's it at now, and at what point do you have to turn off the spillway?
That's being reevaluated by our technical teams on that endpoint. I think nobody wants to get any closer. Again, that's subject to much discussion and further investigation. About 2,100, 22.